Okay, here's introduction into Greek mathematics, and I'm dividing this into two parts. The first part is sort of a brief history of ancient Greece, along with some mathematics, and the second part is just about introduction to the Pythagoreans, which is the best place to start the discussion of mathematics of ancient Greece. Okay, so again, I'm going to give you a lot of dates and timeline. I like to locate things in time and in place, and that helps me understand them better. So I want to give you a little sense of Greek culture. It's later than the cultures that we talked about. Pre 1600, we had migrations into Greece from Ionia and Aeolia. 1600 to 1100 BCE, it's the Mycenaean culture. And if you've read or heard about the Iliad and the Odyssey, the Trojan War, it's that culture that depicts. And this empire included Crete and Sparta, as well as a lot of the Grecian islands, including Rhodes in Asia Minor near Turkey. And the Mycenaeans were a seafaring trading culture. And that, again, that was some pretty typical of ancient Greece, was to be traders and to be seafarers. And 1100 to 800 is the Greek Dark Ages, and this is post Trojan War, and one thought that was a pretty apocalyptic war. And this is where sort of the oral tradition that led to the creation of the Iliad and the Odyssey and other things. It's where their ascendants. And the Greeks continue to go to sea, and at this point it seems it was post and pre-literate. In other words, there was no writing. Now about 800 BCE is what we think of as Greek culture begins to emerge from the Dark Ages. And they absorbed the Phoenician alphabet, and Phoenicia was a culture around the Mediterranean at that time. And so the Greeks began to continue to take to the sea, and they started to establish colonies, probably trading colonies away from the Grecian mainland, and it was in the Aegean Sea and the Eastern Mediterranean. And this is when the Iliad and the Odyssey started to take written form. 776 was when the first Olympics were held. So here's a map of ancient Greece around 550 BC, so a few centuries after the end of the Dark Ages. And if you look around this area, the things that are pink and green and this brownish color, all here are Greek, or one form or another of Greeks. And then the sort of brownish down here, the purplish, is the Phoenician um, uh, culture. You can see that there was inroads into present-day Europe, but you see that most of this region was Grecian in some fashion, including major parts of Italy, Sicily, and then into Asia Minor, so over along the coast of Turkey and around the Black Sea. So it was a pretty extensive empire by that point. Okay, this stuff fascinates me, so I don't know. I can get a little bit carried away. Apologies. Okay, so back to Greek history. Between 800 and 600, we get these migrations away from the mainland, and there was colonies in Egypt, Sicily, Perga, and southern Italy are established. So again, I just want to go back here to show you this. Perga is, I'm trying to see if you can't really see it on here, but it's in here. And that's where, that's going to be, an island where some Greek mathematicians come from. That's why I'm trying to point that out. So we'll come back to that later. And then where the Pythagoreans were, over here you can see an island, if you look really closely, called Samos, and that's where Pythagoras was from. And in the next video, you'll hear a lot more about him and them. And then over here, you can see colonies that the Greeks had in Sicily and also in Greece. Okay, again, we'll see those later. Sorry, I went to backtrack there. So anyway, 600 to 330 is what we think of as high classical Greek culture, and that's the Athens and Athenian democracy and Socrates and Plato and all that kind of thing, and then so we'll talk a little bit more about that. Around 480 is the when the Persians invaded Greece, and Greece was a bunch of small city states, and they were united in some degree, in some fashions, but they were not. They were politically independent. They would unite again against the Persians. They did, and look at the movie 300 if you want to get like an accurate historical depiction, almost like a documentary of the Persian invasion. Okay, and then around the 400s, and is this sort of the late 400s is when Socrates and the great playwrights flourished, and the Parthenon was built, and Athens emerged as at least the dominant intellectual city-state. So around 405 were the Peloponnesian Wars, and these were like an intra-Grecian war among the city-states, and so Athens and Sparta and some other places. And so Sparta won that war, and Athens was just sort of exhausted. And nonetheless, even though Sparta won the war, Athens still continued to flourish. And again, the high culture that we think of as Greeks, that was the center of it. And in fact, the Spartan Empire faltered. And again, when it faltered, the Greek city-states started to fight among themselves again. So about 70 years later, King Philip of Macedon won a decisive victory and became the ruler of all the Greeks. And he was assassinated for mysterious reasons. And that's when his son Alexander assumed power and just happened to conquer most of the known world. And so this century, this era 323 to 30 BCE, it may not be as famous as sort of the high Athenian culture, but you'll see a lot of the mathematics took place during this, and there was a lot of cultural advances, and this is when sort of the Greek Empire was at its zenith. And here's an example of the Greek reach then. And when I say conquer the known world, you can see it stopped with the Alps and the Caucasian mountains toward Eurasia, and what we now think of as Russia. And look at all the land. It conquered pretty much to the Ganges River, and also it conquered Egypt. Even though Egypt still had some political autonomy, the culture became Grecian after that. So when you think of Antony and Cleopatra and things like that, it was Egyptian, but it was very heavily influenced by the Greeks. Okay. So 387 is important because that's the founding of Plato's Academy, and that lasted in some fashion or another for another 800 years. And Plato's Academy was his school, his philosophical school, where I don't know if he held classes the way that we might think of, but it was a research institute, and it was where people came to learn. And Aristotle started out at Plato's Academy, and in 334, Aristotle founded the Lyceum, which again is used today to signify like a house of learning or a place of learning. And it was lost, but then the remains were found. And in the picture on the left, we see the road to Plato's Academy in Athens, and here you can start to see it. If you look, you can see outlines of what look like structures, and those are the remains of Aristotle's Lyceum, which was his school. Okay. So more Greeks. 300 to 200 is considered the golden age of Greek mathematics, and that's the time of Euclid, Apollonius of Perga. See, that's why I wanted to go find Perga. It's where Apollonius was from, and Archimedes. Now, in 250 to 200 BCE, the Romans began to take over the world, and they were fighting the Greeks in Sicily. It's called the Punic Wars, and they conquered other Greek colonies. And even though the Romans eventually prevailed in that military struggle, Greek culture still survived and it persisted, especially in Greece and Alexandria, and it had a profound influence on Rome for hundreds of years. And the Greek peninsula fell to the Romans in 150, but the Greeks still sort of held Egypt, but that fell in about 30 BCE, but things continued, and even though that Egypt was a colony of Rome, Greek culture was still ascendant. The Romans really didn't mess with you as long as you bowed down to them and said you were they were your daddy. They would let you continue to run your own affairs to a large degree, as long as you didn't cause trouble. If you cause trouble, that's a whole other matter. So the era from 250 CE, sorry, I don't know why I wrote AD there, just habit, to 400 is called the Silver Age of Greek mathematics. That was centered in Alexandria. And what happened is after the Golden Age in 200, sort of Greek mathematics, it was still there. There was a lot of practical mathematics and astronomy. But as a pure mathematics, it sort of wasn't, as far as we know at least, it got stale. But then there was sort of this rekindling of the ideas of Greek mathematics, very conscious rekindling around the time of 250 to 400 in Alexandria. Okay, so again, here's things by about 200 BC, and you can see that the yellow and green, the gold, blue, and gray are the extent of the Roman Empire in 200. You can see that by the year 0, yellow, green, and tan were certainly added to the Roman Empire, and then the pink was added in about 180. So you see all this area gradually, which had been Phoenician and which had been Greek, gradually was added to the Roman Empire. So it was an extensive empire. Again, over here is where Alexandria is, right on the coast here. And again, that was still a center of learning and of mathematics. So I want to talk, before I leave, a little bit about the birth of pure mathematics. Thales in 625, somewhere between his birth and death, obviously, he stated some basic geometrical theorems. I'll give you the flavor of those, and then sort of between this, this roughly chopping these things up. You have the Pythagoreans in the mid to late 500s, and he brought logical and creative mathematics and had rudimentary notions of proof and theorems. And this maybe is this is the birth of a new way of doing mathematics. Then you had Zeno, and I'm mentioning him in his paradoxes because he posed his paradoxes were actually logical. He was trying to poke holes in some logical foundations of Greek thought, and we may talk about some of those. Between 450 and 350, this is post-Pythagorean, and then you had the mathematician Hippocrates and Eudoxus, and they sort of discovered, they really pushed mathematics forward, and they analyzed several important mathematical problems and discovered fundamental notions, and including the method of exhaustion, which is a way of showing two things are equal by showing that neither is greater than the other. So to show that A is equal to B, you show that A can't be greater than B, and you show that A can't be less than B, and so that means they're equal. And so this is actually still used today in a different format, but Eudoxus was supposed to have come up with this method of exhaustion. Not because if it was exhausting, even though it might have been, but because you exhausted the difference between two quantities in that fashion. And 375 to 320 is sort of is when a lot of the philosophical ferment was going on. And these philosophies greatly informed mathematics, so Plato and Aristotle. I mentioned about Plato's academy was founded, and it's in this period around here, that geometry became the dominant language for pure mathematics. And I'll talk about that in class, but anyway, we'll talk about that later. So the golden age of mathematics, this is where we have Euclid, and Euclid wrote 12 books of geometry, the Elements, and they sort of encapsulated all the basic knowledge of mathematics at that time. It wasn't the advanced cutting-edge mathematics. In fact, Euclid was supposed to have written some books in that realm, but they're lost. But the Elements came around 300. But he established, well, it had been established before him, but he sort of presented things in this, what I call Euclidean language, and people like Archimedes and Apollonius both they expressed their mathematics geometrically, though Archimedes did some other things as well. But the idea is that to prove mathematics, you had to put it in terms of geometry, and it's amazing what you can put in terms of geometry. You can put not infinite series, but you can put geometric series. You can put prime number theory, and you'll see some of that. in terms of geometry. So everything was done geometrically. And we'll talk more about what exactly that meant. Again, Apollonius, who was between Euclid and Archimedes, so he was in the late to middle 200s. Archimedes was more the middle. I'm sorry, Apollonius would have been the early early 200s, so near 300 in the mid 200s, and then Apollonius was mid 200s, and then the late 200s, so close to the year 200. So Apollonius discovered conic sections, and again, millennia later, these conic sections became analytic geometry, and analytic geometry is kind of the key of the mathematics that brought us to the moon. It's the study of, well, we'll get to what that is. Archimedes discovered and articulated the definition and the famous approximation of 22 sevenths of what we would call pi. He refines the process of exhaustion and learns how to find areas of objects in a method that's very similar in spirit to integration. And he invents mechanical curves such as the spiral, and he explores their property. Now, the language of geometry was based on what we consider ruler and compass, so straight lines and circles. He figured out devices, sort of, in a sense, they were mental devices, not necessarily physical devices, but they could be physical devices that created curves that you could not create by using circles and straight lines. So again, Euclidean geometry is what can you create from circles and straight lines, and then sort of these mechanical curves. Well, what other curves can we create through things that don't involve circles and straight lines? That's kind of abstract and long-winded, but so as I mentioned before, Greek mathematics sort of stagnated under Rome, and pure Roman mathematics, as far as we know, is largely non-existent. And it was thought that during sort of after 200 BCE until about 250 AD, is that this knowledge of Greek mathematics was slowly being lost, and that most mathematicians wouldn't have understood the works of the Golden Age, so the works of Apollonius and Archimedes and others. But there was a resurgence in around 250. Again, I don't know why I wrote AD. And it's the last gasp of Greek mathematics, and it was centered in Alexandria. And Diophantus created a system that has similarities with algebra, and there's some notation, and we'll look at that. And then we have the work of Pappus, who did a lot of analysis using geometrical methods in the early 300s. We really won't talk too much about him. And you can end this phase with the murder of Hypatia in about 390, and she's the most famous female mathematician of antiquity, and it was by a mob. And the causes of the murder were complex. She was on the ruling side of her father, I think, had been involved in the ruling class in Alexandria. And she was pagan, meaning pre-Christian. And so there's some thought that her murder was done by a Christian mob, sort of in the transition of times, in the political turmoil that sort of that signaled the advent of Christianity in many places. So again, we will talk about that a little bit. But I want to close just on a couple of slides just to talk about what makes mathematics different, Greek mathematics from what preceded it. You'll see, of course, but it's abstract and there's propositions, and the concerns are largely unrelated to the real world. Mathematics cannot just be asserted. Like, let's say the Babylonians, here's how you solve something. Everything must be proved. And it was a theorem-proof mode of reasoning. And, so like if there was a Pythagorean theorem, the Greeks would have said, how do we prove that? And you can interpret certain works of Euclid as being the quadratic equation. Again, we're not going to go into that very deeply. During this Greek time, there was a geometric mode of reasoning, and it was using a ruler and a compass, so straight lines and circles, and that was the gold standard. There were rigorous standards of proof. even by today's standards. I mean, we may find philosophical shortcomings in some of what they did, but the proofs are bona fide proofs, and they can be quite complicated. It's assembled in books, not just Euclid, but other people wrote books, and most of them are lost, unfortunately, and it's difficult. It's challenging. So what gave rise? Some people say that the seafaring nature of the Greeks, they were curious about things, curious about frontiers, both physical and intellectual. Um, the culture was very mercantile, based on trading. So there's some people that think that they not only traded in physical goods but in intellectual ideas, and so they would grab things from the Babylonians, grab things from the Phoenicians, like the alphabet, grab things from Egyptians. It's not clear to the degree to which that happened, and that's not one of my areas of expertise. People get very, very passionate about that, and I've got spanked for it, for sticking my neck out. There was a real independence of culture and politics, even though the city-states were united. They were at war, as we showed, and they were separate political entities. So there was some sort of independence. So this political independence somehow fostered intellectual independence, affluence. And I should add here, I'll add it. I should have written it down in here, but with influence came slavery. So they had a lot more leisure time. Some of the slaves also brought knowledge. The stories that I've read is that some of the slaves, especially in rich households, were scholars from other areas that the Greeks, bought and stole. And so some of these slaves educated people in ways of other cultures. So slavery, both in terms of leisure time, but it could be the slaves themselves, brought knowledge into the culture. Now, there's an evolution of a belief from the Greeks in these cosmic powers to a more neutral force that reveals itself through logic. There's this notion of the Greek gods. People like Aristotle, it's very, very doubtful that that's what they believed, and they believed in more complex and distant gods. Aristotle did, that did not meddle in human affairs, that you had to use science and logic to sort of uncover, the divine, so to speak. And Euclid did that, as did Plato. We really don't know much about the Greeks. We have more hard evidence, I mean that literally, about the Mesopotamians and the Babylonians than we do about the Greeks, who also used papyri and paper. By Mesopotamians, I mean the ancient Babylonians. They wrote on those tablets that we talked about. Greek libraries were destroyed through time, through war. So there's almost everything, that a lot of the places where they stored literature disappeared. I've read that we have fewer surviving written artifacts, pre-300 Grecian artifacts, than we do of Egypt. The earliest accounts we have of Euclid's Elements are from 400 in the Common Era, so 700 years at least after the original. That's a long time. Much of Greek mathematics came to us via Latin translations of Arabic translations, well over 1,000 years after that. So translations of translations, as well as things like, almost millennia, 700-year-old accounts of original works. And again, error gets introduced into texts. It's a game of intellectual telephone. There were lost histories of mathematics. There's one by Eudemus of Rhodes, and that's gone. And, I used to think, if you could give me one book, that would be the book that I would want. We have fragments of the early works of Aristotle and Plato. But how reliable are these sources, especially when Aristotle was talking about the Pythagoreans, which were 200 years before him, and he does talk about them. So anyway, we really don't know as much as we would like to know. We know a lot, but there's so much uncertainty with the ancient Greeks, and that's important to keep in mind. So a little bit about Thales and Pythagoras, and then that'll be my last slide, and I'll leave a discussion of Pythagoras to the next set of videos. Next video, not next set of videos, just one video. So Thales, one of the things that he is thought to have proved is that the angles and the opposite angles in an isosceles triangle are themselves equal. So I need some context that a isosceles triangle in this conception had equal sides. He showed that the angles were also equal. And the way that he thought to have done it, some people think, is he just bisected, the line from B down to the base, and then folded the two triangles on top of one another. They fit, angles equal. But there might have been some other ways. Another thing he thought that is ascribed to Thales, again, this is pretty early, is that any triangle inscribed in a semicircle is a right triangle. So if you have the hypotenuse of a triangle to be a diameter, and then you create a triangle by moving this point B anywhere on the circle, sorry, it's horrible, that angle is going to be a right angle. And he is thought to have proven both of these things. So there's a brief taste of the mathematics. We'll see much more of it when we go to Pythagoras in the next video. So thanks, and when you get a chance, look at the next video. Bye-bye.